Hello, everyone. In this video, we will discuss derivatives of hyperbolic functions. Derivatives of hyperbolic functions. These are the derivatives of the 6 basic hyperbolic functions. Which are valid whenever x belongs in the domain of the hyperbolic function. Review of hyperbolic identities. These identities may be helpful in rewriting the function to be differentiated and in simplifying the resulting derivative. Reciprocal identities. Reduction identities. Pythagorean hyperbolic identities. Double of argument identities. Half argument identities. Sum or difference of arguments identities. Examples. Find the derivative. Number 1. F of x equals 2 times the hyperbolic cosecant of x times the hyperbolic cotangent of x. Solution. F prime of x is the derivative of f with respect to x. Apply the constant multiple rule and the product rule. And differentiate using hyperbolic function rules. Simplify the derivative by factoring out a common factor. Thus, f prime of x equals negative 2 times the hyperbolic cosecant of x times the quantity of the square of hyperbolic cotangent of x plus the square of hyperbolic cosecant of x. Number 2. F of x equals 1 all over the quantity of hyperbolic sine of negative x minus x. Solution. To be able to use a basic hyperbolic function rule, rewrite f of x using a negative argument identity. F of x becomes the negative of 1 all over the quantity hyperbolic sine of x plus x. F prime of x is the derivative of f with respect to x. Apply the quotient rule. Differentiate using basic differentiation rules and a hyperbolic function rule. Simplify the derivative. The first term in the numerator becomes 0. Then combine the two negative signs. Consequently, f prime of x equals the quantity of hyperbolic cosine of x plus 1 all over the square of quantity of hyperbolic sine of x plus x. Number 3. Y equals the hyperbolic sine of 2x all over the quantity of hyperbolic cosine of 2x plus 1. Solution. To simplify the differentiation process, rewrite y using a half-argument identity. Where alpha equals 2x. Y becomes the hyperbolic tangent of x, whose derivative is easier to find than the given y. dy dx is the derivative of y with respect to x. Differentiate using a hyperbolic function rule. Therefore, dy dx is equal to the square of hyperbolic secant of x. Number 4. W equals the quantity 1 plus the square of hyperbolic tangent of z over 2 all over the quantity 2 times the hyperbolic tangent of z over 2. Solution. To simplify the differentiation process, rewrite W using a double argument identity, where alpha equals z over 2. W becomes the hyperbolic cotangent of z, whose derivative is easier to find than the given W. dW dz is the derivative of W with respect to z. Differentiate using a hyperbolic function rule. Hence, dW dz equals the negative of the square of hyperbolic cosecant of z. Number 5. F of x equals the hyperbolic sine of x all over the quantity of x squared plus 4x plus 4. Solution. F prime of x is the derivative of f with respect to x. Apply the quotient rule. Differentiate using basic differentiation rules and a hyperbolic function rule. Simplify the derivative by factoring the polynomial on each term of the numerator and factoring the denominator. Next, divide out a common factor between the numerator and the denominator. Multiply the factors in the first term and then simplify further using the definition of hyperbolic functions. Hence, f prime of x equals the quantity x times the hyperbolic cosine of x plus 2 times e raised to negative x all over the cube of quantity x plus 2. Number 6. Y equals e raised to quantity x plus 5 times the hyperbolic tangent of x. Solution. To be able to use basic differentiation rules, rewrite y using a property of exponent. Apply the constant multiple rule and the product rule. Differentiate using exponential and hyperbolic function rule. And then simplify the derivative by factoring out a common factor and using a property of exponent to combine the factors outside the brackets. Thus, dy dx equals e raised to quantity x plus 5 times the quantity of hyperbolic tangent of x plus the square of hyperbolic secant of x. Thank you for watching. Please like this video and subscribe to Professor Reginald's channel to get the latest updates.